Hi everyone, my project is playing rock, paper, and scissors with computer using computer vision techniques. So in this presentation, I'm going to present my project as following sections. Let's first start with introduction. The idea of this project is to create a simple program on Arduino IDE to complete the three tasks, including recognize which gesture the user gives, generate a choice randomly, and then compare them and use LED light as an output to tell the user whether they win the computer or not. The inspiration of this project are image classification and object detection topics during lectures, and also how to win paper, rock, and scissors in Dr. Kawashima's brain training game on Switch. The aim of this project is to build a model that can reach an accuracy up to 80%. Next, I will go through the workframe of this project. The first step is data collection. Data is collected, labeled, and split on edge impulse. I sampled 423 training data and 74 testing data. They have three labels: paper, rock, and scissors. During the sampling process, there are three main conditions I consider here. First one is the background of the sampled image. The impact of image background is reduced by collecting images in different places with different background and also different time with different daylight conditions. The second one is the difference between the left and right hands, palm and back of hands. I collected the images to make sure this different type of sample are included in the dataset. The third one is different gesture habit by different people. To overcome this problem, I also collected images with the help from my friends. Then, model is ready to be built. I started with setting the image size as 96 by 96, resize mode as Scratch, and transfer learning as the learning method. As a result, features generated are visualized here. Afterwards, the convolutional neural network MobileNet V2 with 20 epochs, 0.005 learning rates, and 20% validation set is chosen here. To minimize the overfitting problem, auto-balanced dataset and data augmentation are also implemented. This trained model results in a 91.8% accuracy in validation set and over 86% in testing set, which is a quite robust model. And then the model is deployed into Arduino IDE. However, you can see here, even with the Eon compiler on, the RAM usage still exceeds the maximum allowed size on Arduino Nano board. Hence, Eon Tuner is used to experiment with different parameters to get the optimized model within the RAM usage of 256 KB. To get a model with best performances on unseen data, model number 5 is chosen, which is the MobileNet V1, as you can see here from the left picture. And to have a better performance, I modified the base model MobileNet V1 to be trainable in the Keras mode. This results in a 100% accuracy in validation set and 83% accuracy in testing set. And this is the final optimal model for now. For the program building section, I modified the deployed model code to have following functionalities. Print the label with highest probability, compare it with computer-generated choice, and output LED signal. And here is a short demonstration of my program. From the demo, we can notice there are still some cases that lasers were recognized as paper, and this was also reflected in the testing data result. Therefore, there are limitations in this project still, and they can be summarized into these three areas. One is the detection of other gesture. Other gesture like a rock and roll or a thumb can be recognized as one of the three label classification since the sample for other gesture has not been collected yet, but they will be included in the future work. The other one is the trade-off between the size and performances of my model. As the comparison shown in previous slides, although those models perform really well, but they could not be deployed into Arduino Nano. And the last one is that I mainly used Edge Impulse user interface for now, but there are lots of more detailed parameters modification in those final layers like dense layer, flatten layer, and drop-off rate in the Keras mode. Hence, my following plan is to use the Keras mode on Edge Impulse to modify the model, or even try other kinds of model to find out the model with optimized size and better performance in real scenario. And that's all. Thank you for listening.